Welcome to Code.py. Now in this series I am trying to cover the fundamentals of NLP with TensorFlow. This is the part 2 of the series of videos. So in the first part what we tried to cover is word encodings using TensorFlow. So we basically took a sample set of a training sentence, and then we used the tokenizer class to create a tokenizer object, and then we used the fit to text function to fit or basically use the training sentence to generate a word tokens in the form that you see right now. So now in this video what we are going to do is basically we will use these tokens and create sequences out of it. So let's get into the coding part. What we'll do is we'll still need the tokenizer class, so let me import that. So from TensorFlow.keras.preprocessing.text import tokenizer. Okay, then we will define a training set of sentences. So define list of sentences. We are going to tokenize these sentences, so let's call it train sentences. Let's pass the example. So it is a sunny day. This is the first example. Let's say the second example is it is a rainy day. Let's say the third example is will it actually rain today? Okay, so let's keep these three examples in the set. Now let's train the tokenizer. So for that we'll set up or call the constructor. Create the, or maybe create is not the right word, initialize. So for that let me define the tokenizer variable, tokenizer, and we will pass the num words. Let's initialize it with the value of 50 because we have 3 sentences, although it won't cross 50, but still. Now let's call the fit on text function to train. So, and in fact let me use a different cell to call this. So train the tokenizer on the training sentence. So tokenizer dot fit on texts, and we will pass the training sentences that we had, and then the third step we will store the word indexes for the words in sentences. For that we will define a word index as dot. So it is going to basically store the word index attribute of the tokenizer class into a variable. Okay, so till this part we actually had covered in the last video itself. So now what we'll get is the word index for the words. Okay, but the objective of this video, like I mentioned, is to actually create sequences out of these words. So for that we will use something called the text to sequences functions, which is part of the tokenizer module itself. So let's create sequences. So this is the text to sequence function, and I'll still pass the same training sentence set, and this will create the sequences. Now if we want to check our word index and the corresponding sequences, let's try to print it and see what's the content of these. So print the word index and sequence. So print, let's use the F format to print. So word index, and we will pass the word index here, and similarly we will print the sequences, and we will pass the sequences keyword. Okay, let's try to print this. So now if we print, we can see we have these three sentences, and the word indexes that we have got is: it is a day, sunny, 5, rainy, 6, will actually rain today, etc. And then the sequence, if we see here, it's nothing but the sequence or the order of occurrence of the different words in the training sentences. So actually it will be much better if we can actually print these along with the actual sentences. So let me call them sentences, and I'll print the training sentences as well. So if we do it like this, now it will be much clear how it is working. So this is the mapping, or this is the token mapping that we have, and now for each of the word it maps to 1. So 1, 2, 3, 5, 4. So sunny is 5, you can see 4, day is 4, so that's why we have this order. Similarly for the second sentence, it is a rainy day, it is 1, 2, 3, 6, 4, and then will it actually rain today? For the will, it is 7, so it starts from 7, 1 which is for it, 8 and 9, 8, 9, 10 which is for actually rain and today. So this is how the sequencing works. Now let's try to do a thing where we, instead of using the already defined data, what if we have a new set of data that basically we have a new set of sentences which have words which are not part of our original set. So let's try to define a new sentence set. And I will pass 2 new sentences. Let's pass a sentence called doesn't. Okay, so let's define it. Does not look like it will rain today. Okay, let this be the first sentence, and then it is a pleasant day. So Pleasant, pleasant day. Let's let the 2 new sentences be these, and then we will again call the text to sequences for these new sentences, and we'll create new sequence instead of the old sequence, but we will not retrain, or we will not basically call the fit on text again. We will simply use the existing tokenizer, and we'll call the text to sequences, and let's see what happens. So new sequences is equal to, using the same tokenizer, we will call the text to sequences, and we will pass the new sentences. Okay, so then we'll get the new sequences, and if we now print the new sentence and new sequence, let's see what we get. So I'll copy the same print statements, new sentences, new sequences, and instead of the training sentence, I'll pass new sentence, and here we will pass new sequence. So if now I print, now you can see what's happening here. So we had a sentence, does not look like it will rain today. Okay, but you see here, it, or for all these words, there is no mapping that exists in the tokens that we have already identified. So in the word index, if you see all these words, does not look like, they don't exist. And because they don't exist, there is no mapping. So all these words have been skipped, and the first word, first word that exists is it. So it has added the code for it, which is 1, and then will, which is 7, and then rain, which is 9, and then today, which is 10. So that's how it has encoded it. And similarly for the second word also, pleasant is missing. So apart from pleasant, everything else had a code. So it is a day, so it is a day 1 2 3 4. That's how it has encoded. Now let's try to use an alternate approach, because if we cannot rely, or we cannot use a tokenizer in this fashion, because this is just a sample data set. We are bound to receive words as more and more sentences or more and more data gets added. There is a high probability that we may not be getting the right mapping, or we may not be getting mapping for all the words, and we are bound to encounter new words every now and then. So there is a kind of workaround for this, where we can pass a default value for certain words which are not part of our token list while training the tokenizer initially, which is the out of vocabulary token. So let's see how that out of vocabulary token works. So set up the tokenizer again with OOV token. That's the name of the variable. Let's see how it works. So we will retrain our tokenizer, still on the old data set only, but with this new attribute set. So num words I'll still pass as 50, and this time we'll pass out of OOV token, and let's call the OOV token, or let's define the OOV token with some sort of unique code. Let's say it's OOV, and now we will try to fit. Basically, we are going to repeat the same exercise. So we are going to call the fit on text again on this tokenizer, and then after that, same thing, we will recalculate the word indexes again, and finally again we will see the values and use the same set of print statements and see how it is different this time. So when I print it, so now you see we have this new OOV value, so which basically will take care of any occurrence or any time the word that we are trying to read from a new data set is missing in the token or a sequence of tokens. Then it will be replaced by this default OOV value. Now if you want to see this as an example, what we will do is we will re-execute our code here, where we are using the tokenizer to text basically, and calling the text to sequence on this new set of sentences. So let me copy this and we will re-execute it, and then if we see the values that get stored in this new sentence and new sequence this time, now you can see all the words which are not part of our list of tokens in the word index, they all get replaced by the default OOV token, that is 1. So does not look like, which are all missing, they all get replaced by values 1 1 1 1. And similarly pleasant, which is also missing, also gets replaced by the value 1, which is a code, or which is an encode for OOV, or out of vocabulary attribute. So this is how we can generate, we can basically create sequences out of the tokenized set of words that we have. So that's it for this particular video, and I will continue with the next video in the series, and I'll see you in the next video. Thanks a lot for watching this one. Thank you.